Welcome to Quantum Consciousness, the place where modern science, ancient wisdom, and deep curiosity converge. Introduction: Awakening to the Mystery. Today we are going to explore what consciousness is. It's the one experience we all share, the very essence of our lives. We see, feel, think, remember, and imagine. But where does all this awareness come from? Why is it that we don't just function like machines, running on code and electricity, but instead possess a subjective sense of self? Consciousness, the awareness of being, has puzzled humanity for millennia. It is, in many ways, the most immediate yet most elusive phenomenon we know. It's not a thing we can hold or dissect, yet it defines everything we know about existence. But what if the key to understanding consciousness isn't found only in biology or psychology, but deep in the strange and mysterious world of quantum physics? Could it be that our minds and the universe are more deeply intertwined than we've ever imagined? Chapter 1: The Hard Problem of Being. Consciousness is the state of being aware, not only of the world but also of ourselves. It includes everything from the color red, the smell of coffee, the feeling of joy, to the awareness of time and the ability to reflect. In scientific terms, it's the combination of perception, emotion, cognition, and self-awareness. But here's the mystery. Despite all of our scientific advances, we still don't understand how physical processes in the brain create subjective experience. You can map brain activity. You can identify which regions fire when someone sees a face, feels pain, or hears music. But none of this explains why those brain activities are accompanied by an inner experience. This is known as the hard problem of consciousness, a term coined by philosopher David Chalmers. The hard problem asks, why does any of this brain activity feel like anything at all? If the brain is just a network of neurons exchanging electrical signals, why should that produce the feeling of being alive, of being you? Chapter 2: The Limits of Complexity. Most current scientific theories treat consciousness as an emergent property of complex information processing. The idea is that once the brain reaches a certain level of complexity, awareness just emerges. It's similar to how wetness emerges from water molecules. A single molecule isn't wet, but gather enough of them, and suddenly you have something you can feel. But many scientists and philosophers argue that this explanation is incomplete. Complexity alone doesn't account for subjectivity. Computers are complex. They can play chess, recognize faces, even mimic conversation. But do they feel anything? Is your smartphone aware of itself? Probably not. So what's missing? This gap has led some to look elsewhere, to a different framework of reality that might help explain the puzzle of consciousness. That framework is quantum physics. Chapter 3: Reality in Superposition. Quantum physics is the science of the very small, atoms, electrons, photons, and the fundamental particles that make up the universe. In this world, reality behaves in ways that defy our everyday experience. Particles can exist in multiple states at once, a phenomenon known as superposition. They don't seem to occupy a single location, but many possibilities simultaneously. And when we measure them, when we observe them, they collapse into a definite state. This is most famously illustrated in the double-slit experiment. When electrons are fired at a barrier with two slits, they create an interference pattern on the screen behind it, suggesting they've behaved like waves, going through both slits at once. But when we try to measure which slit the electron goes through, the interference pattern disappears. The electron behaves like a particle. It's as if the act of observing changes reality itself. This strange behavior is what led many physicists to question the nature of observation, measurement, and even consciousness. Chapter 4: The Observer Effect. In quantum mechanics, the observer effect refers to the way measurement seems to affect the outcome of a quantum event. Some interpretations suggest that consciousness may play a key role in the process. Take the famous thought experiment of Schrödinger's cat. A cat is placed in a sealed box with a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, the poison is released and the cat dies. If not, the cat lives. According to quantum mechanics, until we observe the system, the atom is in a superposition of decayed and not decayed. That means the cat is simultaneously alive and dead until someone opens the box. It's a metaphor, of course, but it highlights a strange idea that the act of observation, possibly by a conscious being, might be what determines reality. Does this mean our minds affect the universe? Is consciousness not just a product of the universe, but a participant in shaping it? Chapter 5: The Mind and the Measurement. This is where science touches the edge of philosophy. Some physicists, such as Eugene Wigner, propose that consciousness is necessary for the collapse of the wave function, the process by which quantum possibilities become actual events. Others, like John von Neumann, extended quantum theory to include the observer as part of the system, not separate from it. These ideas are controversial. Many scientists argue that the observer effect doesn't require a conscious observer, only interaction with another physical system, like a detector. But the questions persist. If observation plays a role in shaping quantum events, and consciousness is the most sophisticated form of observation we know, could there be a deeper connection? Chapter 6: Orch-OR, the Quantum Brain Theory. Enter the Orch-OR theory, short for Orchestrated Objective Reduction, proposed by physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff. This theory suggests that consciousness arises from quantum processes occurring within the brain's neurons, not at the level of synapses, but within tiny structures called microtubules. Microtubules are part of the cell's internal framework. Penrose and Hameroff argue that quantum information could be processed within these structures, creating momentary quantum superpositions, events that collapse into conscious moments. In this theory, consciousness isn't just an emergent property of neurons firing, but a fundamental part of quantum reality, with the brain acting like a quantum computer. Each moment of awareness is tied to a quantum event, a collapse of the wave function. Consciousness, in this view, is not passive. It is active. It is part of the way the universe evolves. Chapter 7: The Controversy of Quantum Consciousness. The Orch-OR theory is bold and highly controversial. Many neuroscientists argue that the brain is too warm and wet for delicate quantum states to survive. Quantum coherence is easily disrupted by temperature and noise, conditions that are common in biological systems. Others say that even if quantum events occur in microtubules, there's no evidence they cause consciousness. Correlation is not causation. Still, research continues. Experiments are underway to test whether microtubules can sustain quantum states. Quantum biology, a new and growing field, is exploring how quantum effects play roles in processes like photosynthesis, bird navigation, and possibly the brain. Chapter 8: Panpsychism and the Universal Mind. Beyond Orch-OR, some scientists and philosophers explore even more radical ideas, like panpsychism, the view that consciousness is a fundamental property of the universe, like space, time, or mass. In this view, all matter possesses some form of consciousness, perhaps extremely simple in most cases, but present everywhere. The human mind is simply a highly organized form of this universal consciousness. This resonates with some interpretations of quantum theory. If particles respond to observation, could they possess a primitive form of awareness? Could consciousness be not something we have, but something we are, a basic feature of existence? It's a view echoed in ancient philosophies, from Hindu Vedanta to Buddhist mind science to indigenous cosmologies, all of which describe consciousness as a universal field, not confined to individual brains. Modern science may now be rediscovering what ancient wisdom traditions intuited long ago. Chapter 9: The Conscious Universe. If consciousness is fundamental, woven into the fabric of quantum reality, then everything we think we know about the universe changes. It would mean that the universe is not a cold, dead mechanism, but a living process in which awareness plays a central role. It would mean that the separation between mind and matter, between observer and observed, is an illusion. This would not only solve the mystery of consciousness, it would transform our understanding of space, time, and existence itself. It could even explain why we are here, not just as biological organisms, but as conscious participants in a conscious universe. Conclusion: to know the universe, know yourself. Consciousness remains one of the deepest mysteries we face. Quantum physics has opened the door to new ways of thinking, but it has also reminded us how strange and incomprehensible reality truly is. Maybe the mind is not just in the brain. Maybe it's in the stars, the atoms, and the spaces in between.